Okay, good afternoon, Form 5 students, or Form 5 students. Okay, I know you all feel very tired lah, because this is the second day you all go back to the school, right? So it's normal lah. It's normal you all feel tired because you need some time to back to normal lah, everyone. Because now the worst thing is you need to get up very early now. So everyone cannot tahan lah when you wake up so early, right? Then go to school. Go to school cannot walk, cannot talk so much, right? Cannot walk here and there. Teacher always scold you. Cannot walk here, cannot walk there. Go canteen also have to walk like a robot, isn't it? Okay. But slowly now you will used to it now, huh? And the rules are the school rules also. I think slowly will be loosened now. Day by day we will loosen the school rules. Because right now we have to do like this, because the Japatan the health ministry they are watching us, the police they are watching the student. Every day the police come to school to see the student. So see whether the school can control the student or not. The police come and check. So at the beginning, all the school they control the student quite tight lah. But I think slowly, if nothing happen, so slowly everything will back to normal. Don't need to worry so much. Okay. All right. So starting, I know you're very busy now when school is open already. So you need to sleep early. You need to have more time to do your homework. Okay, so I believe you all read the message in the WhatsApp already, right? So starting next week now, you only attend online class of physics tuition once a week only. So if you are Tuesday group, you follow the Tuesday group one now. If you are Thursday group, so you follow the Thursday group one. Both days Tuesday and Thursday I will teach the same thing lah. So you just join any one of the day can already, okay? So that you can have more time, you can do yourself, do your homework, do your revision, okay? So starting, remember now, next week now, I hope you still remember your tuition day is what day, or Tuesday or Thursday. So you follow your own days lah. If Tuesday, you follow Tuesday one. Back to your normal time lah. Last time the tuition time also more or less like that, isn't it? If you are Thursday, you follow the Thursday one, okay? Sorry, sir, just now I cannot hear you. Chuan cannot hear me. Other student can hear me or not? Chan Jingyi, can you hear me?
Yes, teacher.
Can. Raymond, can you hear me?
Yes, sir.
Chuan, you cannot hear. You go out, then you come in again. Chuan, log out, then come in again. Okay? Okay lah, So, okay lah. So, if you only need tuition physics for one time only, so would be so tired. Okay? Yeah. Okay, Chuan, now can hear me or not, Chuan?
Yes, sir.
Now can already, Okay lah. So we continue our lesson now. So last lesson we started this your Form 5, Chapter 5, radioactivity, correct not? We have finished lesson 1, okay? Last lesson now. So today we will start doing lesson 2, okay? Lesson 2, which is a longer lesson, okay? So I share the paper now. So you see the paper now, your lesson 2 paper. Okay, lesson 2 is analyzing radioactivity decay. Decay now. So the keyword here is decay. Okay, decay means it's a process of the radioactive substances at the beginning is very active, So it want to become stable. It becomes stabilized. So the process of slowing down and finally becomes stable. So the process is called decaying. Decay now. Decay means beginning very active, then it slowly slow down a bit, slow down a bit, slow down a bit, and finally become stable. This process are from very active, then slowly to become very stable. Stable already means are not active already. So this process from active to become not active anymore. So it's called decay process. For us to easy to understand means it's a process of dying. The radioactive thing dying, become stable means die already. Okay. Okay, dying process lah. So it's called decay process. Okay. Uh, Now I want you to look at this paper lah. Someone haven't switched off your mic. Can you? The mic. Chuang, I think your mic not off, isn't it? Chuang, off already. Okay. First, what is radioactivity? Okay. What radioactivity is? The definition you must know. Radioactivity is spontaneous disintegration. Okay, spontaneous means not planned one, suddenly happen one. Anytime can happen. That is called spontaneous disintegration. Disintegration means break up. Okay, something break up. So disintegration. Suddenly happen disintegration, suddenly break up of an unstable nucleus. Unstable means active. Active is unstable. Unstable nucleus into more stable nucleus. You see, from unstable, which is active, one to become stable. So this is spontaneous disintegration. Disintegration means breaking up process from unstable to become more stable. So this process is called radioactivity. Okay. Not only that, when from unstable to become more stable, right, it will release a lot of energy accompanied by emissions of energetic particles, energy lah. Example, radioactive ray, alpha, beta, gamma lah. So we call it photon. Okay, photon means particles with a lot of energy. So we call it photon, release of photon. Okay. So remember the definition. Radioactivity is a spontaneous disintegration of unstable nucleus to become more stable. At the same time, release energetic particles, or we call them radioactive ray, alpha, beta, gamma, or just call them photons. Photons is a new word for you. Photon means energy, carry a lot of energy. The particle carry energy, so we call photon. Okay, you see the diagram. Start from unstable. Unstable means very active. Slowly become more stable. And then at this time, it will release the photon, release the energetic photon here. Okay, all right. Now the explanation of spontaneous is what? Process is said to be spontaneous because it is not influenced by any physical factors such as time, pressure, temperature, meaning that whether the process carry on or not carry on, not affected by anything, not affected by time, not affected by the pressure, even though the temperature. No, you want to happen, it certainly can happen one. So not affected by anything. That's why we call them spontaneous. Okay, spontaneous process. That means it's very dangerous. The process of decaying cannot be predict one. You cannot predict when it will happen. You cannot predict, cannot plan when it will happen, cannot. So everything is by nature. Okay, so it's very dangerous. Okay, the decay occur randomly. Randomly means anytime can happen because each atom has same probability of decay at moment of time, of any moment of time. So when you have 100,000 atoms, so every atoms will have the same chance, same probability to experience the decay process. Same chances given to all the atoms, same one, anytime, anyone can happen. Cannot be predicted. Okay? Yeah. So this one definition here now, you all must know. Okay, the next one is types of photon. There are three types of photon. Three kinds of radiation can be emitted. Okay, this one you remember. Alpha, first one is alpha. Alpha particles. The symbol is like that. Alpha. Okay. Second one is beta particles. Beta symbol is like that. You write. Then you write B. Okay. Beta. Alpha, beta. And one more is gamma. Gamma, you write like this. Okay. Gamma. Like this. So in your syllabus, you only study these three. Alpha, beta, gamma. You see now. Alpha, we call it particles. Beta, we say particle. But gamma, no. Gamma is ray. Gamma ray. Is it different? It means alpha is particle. Beta is particle. But gamma, no. Gamma is a types of ray. Okay? It's not particle. Okay. We know this alpha, beta, gamma are very, very dangerous. They are very, very dangerous one. Okay? That's why we need to have this detector. Okay? Detector, the one I do it later. Now, I want you to follow me, go to this part first. We have more understanding about this characteristic. This one first. Okay? Characteristics of radioactive emission. Yeah, here. All right? Okay, the characteristics of radioactive emission, the natural characteristic, you see, alpha is helium. This one definitely you have to remember. Alpha is helium particles, helium-24. Okay, helium-24, helium nucleus. Alpha is helium, positive one, positive charge. Beta is fast-moving electron. You see, beta is just moving electron, very fast moving electron. So electron is E -10. Okay. This one is helium alpha. Okay. Beta is fast moving electron. Then gamma ray is electromagnetic wave. Electromagnetic. When you study chapter 1, you remember the last part of chapter 1, electromagnetic wave. You have so many, like you have radio wave, ultraviolet, infrared, X-ray, light, gamma ray, all these got 7, right? All together. So gamma is one of them, one of the electromagnetic wave, the last one, okay? So gamma ray is electromagnetic wave. Remember, no? This one is a natural. Alpha, helium. Beta, fast-moving electron. Gamma, electromagnetic wave. So this one is particles. This one is ray or wave. Okay. So first one, natural characteristic. Remember that? No. You only study alpha, beta, gamma, only 3. Remember. X-ray, you see, X-ray not inside here. I mean, X-ray is not radioactive one, no, not belong to here. So X-ray is still lower, lower compared to alpha, beta, gamma. Alpha, beta, gamma is more dangerous than X-ray. X-ray is safe, safe to scan, okay? But this alpha, beta, gamma is not safe. You cannot let this thing go inside your body, one, okay? Yeah. Number 2, the charge. Okay. Charge alpha positive 2, okay? 2 proton, so 2 positive lah. Beta is electron, so -1, negative, okay? Electron. Gamma, no charge one, because electron and magnetic wave is neutral one, no charge. So remember, alpha positive 2, positive, beta -1, gamma no charge. And then the speed, how fast it travel. And now you see, alpha can carry a very slow, 10% of speed of the light. A bit slow, only 10% of speed of the light. Beta slightly faster. Beta almost, you see 99% of speed of light already. We're quite fast already, no. This is speed of light, 3 times 10 to the power 8. 1 second now you can travel 3, then behind x0 meter, very far, So can up to 99% already beta, very fast. Gamma, speed of light. Gamma exactly moving with the speed of light. This speed 3 times 10 power 8 meter per second, very fast. So gamma can travel very fast. Okay, the speed now remember now, alpha 10% speed of light. Beta can up to 99%. Gamma ray, exactly speed of light. Okay, next one. Next one is ionization. This one you need to listen what is the meaning of that. Ionizing power. Okay, come let me explain to you this one, the meaning. Okay, the meaning of ionizing power. You look at here. This one is alpha, positive charge, right? Alpha travel in the A. When alpha move in the A, right? So because alpha is positive, when it move in the A, right, it will hit the molecule, the A molecule. When it hit the A molecule, the positive charge will be kicked out. It will attract the negative because it's positive, alpha. So meaning that when alpha travel along the A, right, it will split the A molecule now to become positive and negative ion. And then it will split the A molecule to become positive ion, negative ion. The splitting of A molecule by the alpha particles is called ionization. Ionize. Ionize means break them up and then make them to become positive and negative ion. Very easy to understand now because alpha itself is positive. So when it hit the A, right, it will kick out the positive charge inside the A, right? And only attract the negative. So it break out already, kick out positive, only attract the negative. So it divided positive, negative already. So along the way, when alpha travel, all the A molecule will be ionized, right? Actually no good, no good like that. Imagine now when this alpha go inside your body, suddenly this alpha go inside your body, it will ionize all our body cells, your blood cell, nerve cell, all will be ionized. Ionized, you see, your nerve cell, for example, nerve cell to become positive charge and negative charge already. This will totally affect our nerve system. Nerve system is using the charge to send the signal, So when this thing go inside your body, it will interrupt the nerve system. You will become mad, become crazy. Okay? So no good, very dangerous. Ionizing power, okay. Alpha, very strong. Alpha, I tell you, very, very strong ionizing power. Because it's positive. Positive, easily to break the A molecule to positive, negative, break up. So alpha no good. Because of that, alpha cannot travel fast. You know why? Because when it travel, it will keep ionize the A molecule, disturb other people, ionize to make it itself to become very slow. It cannot travel fast. Because he like to ionize the A molecule. So he cannot travel fast and also cannot travel far. Okay? But it has high ionizing power. Okay, Beta ionization is weak, medium, very weak. Because beta is negative, and negative not so, the charge not so strong. That's why the ionization of beta is very weak. Okay, gamma even very, very weak. Okay, but you see, Alpha, right? Ionization very strong means alpha cannot travel fast because it keep ionized, it will make itself slow down. Then gamma, right, can say no ionization, so it will travel very fast. That one dangerous lah. Okay, because no ionization means it never disturb anything, so it just move only, so it can move very fast. Okay, all right. Okay, now I want to ask you one question now. Between alpha, beta, gamma, which one kill people very, very fast? Which one can kill people very fast? Is alpha, beta, or gamma? Likachuan. Likachuan, which one can kill people fast? Raymond, which one can kill people fast? Alpha, beta, or gamma?
I think it's alpha.
Alpha. Okay, let's see. This one who say? Likachuan say gamma. Raymond say alpha. Okay, like this let me explain To kill people fast is gamma. Gamma kill you straight away, very fast. You die very fast because it's very strong power. But alpha, when go inside your body, right, it wouldn't die immediately, It will torture you 1 year, 2 years only, you die slowly. This is the worst. So if for me, I rather take gamma, die faster compared to alpha. Alpha, you suffer a few years of cancer, then only you die, right? Because you know why? This alpha will ionize your body, make your body cell all become abnormal already. So your body cell abnormal means become cancer cell. Okay, so most of the cancer disease happen in the world, right? It's because of alpha particles. Alpha, because it went inside your body, it will disturb your nerve, disturb the charts, right? Ionize it. So become make the cell become abnormal already. When the cells become abnormal, right? So it's called cancer cell, carcinogenic cell. Okay, cancer cell. Okay, so in terms of killing, all this can kill people. Gamma kill very fast. Alpha torture you for a few years before you die. So up to you to choose which one. You want alpha or you want gamma? Okay. Gamma can kill very fast because it penetrates your body straight away, kill the cell, kill your body cell straight away. So you die straight away lah. Okay, no cancer, straight away you die. Alpha go inside slowly, make your body cell abnormal, become cancer, torture you a few years, then you die. Okay, also die also. Okay, Number 5, penetrating power. Penetrate power. Some can go through the wall, some can just stop by a piece of paper only. You see, some very big one. See this diagram. Alpha, right? Penetrating power very low because you see, alpha can just stop by a piece of paper. See alpha, you put a piece of paper also can stop. It cannot go far, cannot go through a piece of paper. Even though our skin, human skin, also can stop alpha, Then how if our skin can stop alpha, how alpha go inside your body? How? Harry Young? If paper our skin can stop the alpha, then how this alpha go inside your body? Harry?
I don't know lah.
You don't know. Ping Yi, what about you? You know or not? Skin can block the alpha, but it still can go inside body, or then how? Okay.
Don't know.
How? Doing Ping Yi?
Don't know.
Don't know. Okay, I tell you. Through your mouth, when you eat the fruit, any food, right? When the food carry alpha, you eat, then it go inside your body already, right? It can went inside your body just like that. Or sometimes too, breathing, when you breathe, it go inside through your nose. Okay? Not necessarily your skin block it. You are safe one, It can go inside through your mouth, through your nose, through your eyes. Your eyes also you can go inside one. Okay? So it's dangerous. Okay, so remember, alpha penetrating power is low. Okay, beta average. Beta can stop by aluminum. Few millimeter aluminum, then you can block the beta. Beta here I block. Then gamma very strong. Gamma, you want to block gamma, you must use very thick, a few centimeter of lead, L-E-A-D, lead. Lead, you learn in chemistry already, right? The only mineral, the only metal can block gamma is lead. Lead, L-E-A-D, lead. Lead must be very thick, very thick, 80 centimeter, very thick. Only can block the gamma ray. Like this concrete, the building concrete, the house wall, this one cannot. Gamma can go through one. So you want to block gamma, right? For example, like your car body cannot block. Gamma can go through. You want to block gamma, you must have lead only. Lead, very thick one, a few cm, very thick. Then we can block the gamma ray. Okay. Just like now, some people, especially men, right? They want to protect their, how to say, their testis, not testis, for human, for human, right? The most important organ is testis, because testis producing sperm, correct not? When this sperm are exposed to alpha, beta, gamma, then very thorough, understand? So the sperm is genetically mutated already, changed already. So when you have child, then your child will become effective one. Okay, that is the reason no one born then become like that already. Okay, it's because radioactive. Okay, so a lot of men now, right, they go and protect their testes by wearing a types of pants, short pants, made by lead. You don't believe, you can search Lazada, Shopee also got one, lead, radioactive protective pants, wear by men one. Okay, the organ need to be protected from alpha, beta, gamma is what is your testis. You need to protect it. For woman, right? Woman, the ovary is deep inside the body, behind, inside. So it's not so dangerous, But for men, the testis is outside one. Outside, so you need to wear something to protect it. So the protection is come from lead. So the short pants is made from lead. Okay, lead, L-E-A-D. Okay, this kind of thing can protect from radiation. So you wear the short pants, good for you, for men especially. Okay, yeah. So penetrating power, this one weak, very low. This one medium. This one high. Can penetrate until stopped by a thick layer of lead only. Okay. Next, range in the air. How far you can travel in the air? Range. So alpha only can travel a few centimeters only in the air. Why? I told you just now, right? Because alpha like to ionize the air molecule. So it ionize the air molecule, it make himself cannot go far. So very short distance, a few centimeters, stop already. Okay. Beta can travel a few meters. Okay. Average now. Gamma can travel a few hundred meters. This one is by nature, by nature it travel a few hundred meters. If with the help of wind, when the wind blow, right, it can travel until the whole world. It happened before. In the years of 1986, right, there's a disaster of radioactive happened in Russia, Ukraine, Chernobyl. You can search in the YouTube, a lot of video you can see. Chernobyl, this is a town in Ukraine, Russia. Okay, so these are radioactive power station, leak, So this alpha, beta, gamma come out. Okay, especially the gamma leak come out. You cannot see, because alpha, beta, gamma no color one, no smell one. You cannot see them. Cannot see them. No smell, no color. Cannot see. Okay, you can only feel your body become very hot when you expose to alpha, beta, gamma. Suddenly you feel your body hot, like burning, that kind of feeling one. Okay. Okay. Then back to the story in Russia, right? This Chernobyl town, right? One of the power stations are using radioactive one leak already. So this gamma ray come out. Then cannot see, nobody knows. Cannot see, cannot smell, right? So until next morning, suddenly, there's a lot of people, a few thousand people all rush to the hospital, say not feeling well, like sunburn, skin burn. So doctor check, they say radioactive already. Then only they realize, it's already power station leak. Then after that, the Russia country is a communist country, right? They never let anybody know, never let the newspaper reporter knows, right? So the other worlds don't know, European country don't know. Then what happened was the wind blow. When the wind blow, this gamma ray, right, is traveling from Russia and then cover the whole European country. Luckily, at that time, the wind blow towards the European side, So the gamma all cover up all the European country. If the wind blow to the east, it will go to China, go to Malaysia. Then that time we were very lucky because wind blow to the west. So this gamma ray travel a few thousand kilometers until reach cover up the whole European country. So there are many people complain now. That time also a lot of people die, like now this COVID-19 now. That time also a lot of people die because of this gamma ray, because of wind blow. Cannot do anything one, one come out already when the wind blow, you cannot go and stop it anymore because you cannot find it. You don't know, no smell how to find. So let it travel naturally, a few thousand kilometers. So all the places this thing go, gamma ray, we kill off everything, plants, animals, human, everything die one. Okay, dangerous or gamma ray. Okay, so it can travel a few hundred, but with the winds, it can go cover up the whole world, right? Okay, next, effective of electric field. Electric field, I want to show you this diagram first, okay? If you are affected by electric field is this one. You look at here, this diagram. Okay, here is negative, here is positive. So this one connect to negative terminal, okay? This one negative terminal, This one connect to positive terminal, this one is positive, okay? Positive, high voltage lah. High voltage positive connect here, so this one become positive. High voltage negative connect here, so this one become negative. So in between here, current cannot flow, but you have electric field. So this is called electric field lah. So here got positive, here negative, so in between got electric field. Okay, got electric field here. So what happened is you put this alpha, beta, gamma, you notice, alpha will attracted to the negative plate because alpha itself is positive. So positive will be attracted to the negative lah. Understand not? Common sense only, right? Whereas this beta is negative, so negative will be attracted to the positive side. Okay. Then this gamma not deflected by electric field at all. It will go straight. You know why now? You know the reason or not? Why gamma goes straight? Not affected by this positive negative charge. Why? 子香, Tan Sixiang, are you there? Tan Sixiang? Sixiang, why gamma goes in a straight line, not affected by the electric field? Why? Liao Xingxiang, are you there? Liao Xingxiang?
Yeah.
Liao Xingxiang, can you explain why gamma goes in straight line?
So it can travel further.
No, I'm asking you why the gamma ray not affected by the negative or positive plate.
neutral.
Yes, correct. Neutral. Song say, yes, Song also say correct, no charge. Gamma, yes, Lee Ka-chon also say correct lah, because gamma is neutral. Neutral means not affected by negative or positive one, so you travel in a straight line. Like this one, alpha is positive, so you are attracted to the negative. Whereas the beta negative, right, attracted to positive law. So remember that. Another thing you need to know, why beta attracted is deflected more compared to alpha. You see, alpha deflected very slow, but this beta deflected very fast, very fast it bend down already. This one very slow. Why? The reason is beta is electron, so it's very small, very light, very small and light, so easy to deflect. The side deflect faster because the mass is very small. Very small things are very easy to deflect. Beta, small, but gamma is helium positive, so it's bigger mass. When bigger mass means the inertia is bigger, so more difficult to deflect. That is the reason why alpha deflects slower, but beta deflect very fast. Understand this diagram? You have to remember, no? In the SPM, they can ask you one, no? When you go to electric field, alpha go to negative, beta go to positive one, gamma straight line. And then this one deflected slowly. This one deflect very fast. Want you? Or no sound already? When school reopen, it's like that. I think very tired. Okay. So this I understand. Okay, now we go back here. Electric field. Okay. Alpha, small deflection towards negative plate. Okay. Beta, large deflection towards positive plate. Go to the positive. This one positive, go to negative. This one negative, go to positive. Okay. But this one deflected more. And gamma, no deflection, straight line. Okay, the reason, now they tell you. The size of deflection alpha smaller than beta. Okay, alpha deflects less compared to beta. The reason is because the mass of alpha bigger than the mass of beta. When the mass is big, right, more difficult to deflect. The sign alpha deflect less because bigger mass, heavy, not easy to deflect when it's heavy. Understand? Beta very light, little, very small, so very easy to deflect. Okay, so understand or not? Raymond, understand? Raymond?
Yes, sir.
Zhixiang, do you understand? Tan Zhixiang, understand? Tan Zhixiang no sound or why? Ping Yi, do you understand? Yeah, now mine are all no sound already. Okay, next, one more to go, is under magnetic field. Okay. Effect of magnetic field. This one I can tell you that guarantee come out one. Okay. Under magnetic field, right? See now, come, let me explain to you first. This one is a bit difficult to understand. When this one is magnet, north, south, so over here got magnetic field. Okay, just now was electric field, now it's magnetic field. Okay, under magnetic field, it will deflect also, you see, but why the alpha go here, why beta go here, why gamma go straight line, the one you know, When you look at this diagram, so we need to explain using Fleming's left hand rule, This hand, Fleming's left hand rule. It determine the direction of the force. Okay, my hand I see, this finger, Fleming left hand rule, right? First finger showing the magnetic field north to south. So north, south, so you point there. Now follow this finger, point there. Okay, because this direction north to south. Okay, And now I take alpha only, alpha direction. Not here, sorry, should be here, alpha. This one cancel. Actually, this one supposed to be alpha lah. Alpha is positive, is current, no? Okay, alpha. Okay, when we take alpha going up like this, right? Alpha, okay, alpha is positive charge, so it's the direction of the current. You learn in chapter 2, right? Electron move to the left, current moves to the right, the valid one. Okay, so alpha is positive charge, so alpha flow here means the current also flow same direction. Electron beta flow here, current the valid is different now. But alpha, right, it flow up, current also flow up, it follow because alpha is positive. When positive charge flow, it show the direction of the current also. That's why this finger show magnetic field from outside point inside. Then your current, this finger point up to the sky. Use your left hand. This one from inside point, outside point inside. This finger point up to the sky. Because it's going up, current going up. Why current going up? Because this is alpha. Alpha go here. I take alpha only, you know. Then you see your notice your thumb point here mean the force lah. So it will push this one to the left side because of force pushing to the left. Follow this hand. Magnet north south. This one point to the sky, point up. This one is current direction. Why current? Because alpha memang is direction of current. Alpha is positive, positive charge flow. Current also flow like that, go up to the sky. Then your thumb point to the left, show the force. So we push the alpha to the left side. So this one showing that this alpha beta is deflected by magnetic field. Okay? In the opposite direction, alpha deflected here, beta no need check already. When alpha go this direction, beta must go here. Because they are this one positive, this one negative, show direction different now. Okay? This one deflected less, this one deflected more. Same reason, because beta very small mass, light, so can deflect very fast. Alpha, big, heavy, difficult to deflect, so it will deflect slower. If this one go to the left, beta will go to the right. Okay? So use Fleming's left hand rule to determine. Then for this diagram, this cross mark magnetic field go into the paper. Magnetic field into your paper. So your this finger point inside your paper. This is magnetic field. You said go into your paper, so point inside. You use your hand test, follow your paper, point inside your paper, this finger. Then I take alpha also. Alpha go up. Alpha is the direction of current so this finger go up like that. So this one magnet go inside the paper, point inside the paper, current go up. Then you see your finger go to left. It's the same. That's why you would push this alpha to the left side. Okay, magnetic force push it go to the left. When alpha this side, beta here this one deflect less, this one deflect more. Okay, same reason now. Yeah, okay, look at the explanation now. Don't sleep, okay? You all don't sleep, have to be strong now. Alpha particle, small deflection. This one deflected a little bit because heavy, big, mass bigger. Beta, last deflection, like this, deflect more in opposite direction to the alpha. Gamma, because it's neutral. Neutral means not affected by magnetic field. It goes straight. Okay? So many already remember now. This radioactive radiation, alpha, beta, gamma, right? It will be affected by magnetic field, deflected by magnetic field, deflected by electric field. So many things you need to learn. Okay. Now I give you a few minutes from 1 to 8, I have explained to you now. Natural characteristic number 1. Number 2, charge, speed, ionizing power, penetrating power, range in the air, effect on electric field, effect on magnetic field, right? Altogether 1 to 8. Okay, take 3 minutes time, read it over, and then put it here. Then I ask you later on, okay? I ask you, you please answer my question, okay? Try now. Okay, now take a few minutes, go read the paper. Okay, come on, start now. Read, okay, you have to read and then try to memorize it. Such as speed, ionizing power, penetrating power, all this, Okay, read it now. Read the paper. Read, wait, you all read now, read, memorize it, all the characteristics. Okay, ready or not? Don't sleep, when you don't sleep, have to be stay strong now. Okay, from 5 already, what to do? Have to be strong now, Don't sleep. Okay, come. When I call your name, so you try to answer. Don't worry. If you don't know the answer, you just say you don't know. Okay? Don't need to worry. Okay, let's start from Hua Su Ming. Hua Su Ming, are you there? Hua Su Ming, can you please come out? Hua Su
Yes,
Ming?
yes,
Hua Su Ming, first question. Okay, can you tell me in terms of penetrating power, alpha how, beta how, gamma how, penetrating power?
Alpha has the lowest penetrating power. Gamma rays has the highest, and beta particles is average.
Yes, correct. That's correct. Half only, not finished yet. No, don't run away. Why? Just now you say alpha low, very weak, right? Gamma very strong. Then, can you give example lah? Alpha can stop by what? Beta can stop by what? Gamma stop by what?
Alpha can stop by paper. Then beta can stop by few mm of aluminium, and gamma ray can stop by few cm of lead.
Yes, very good. Okay, thank you for swimming. The next is Chan Wen Kang. Are you there, Chan Wen Kang? Chan Wen Kang? Chan Wen Kang Okay lah, I call your friend then. Tivish. Chan Wen Kang, microphone cannot talk. The mic cannot talk, I know lah. Tivish, please come up, Tivish.
Yes, yeah.
Tivish, listen to my question now, Tivish. Okay, Tivish.
Yeah. Okay.
In terms of ionizing power, can you tell me in terms of ionizing power, alpha, beta, gamma, how? Ionizing power.
Alpha particle is the strongest. Gamma particles the weakest. Beta particles are
strongest is alpha, then weakest gamma lah,
gamma.
Okay, correct. Okay, so it's here already, now I have one question to ask. What is ionization now? Here say ionizing power, right? What is ionization actually? What is that? What is ionization? Tanwei, are you there? Tanwei, Tanwei.
Yes.
Tanwei, what is ionization?
Ability to split air molecules into positive and negative ion.
Yes, correct. It's a process of breaking up the air molecule into positive ion, negative ion. That process is called ionization. Remember that, Okay. The next question. Tan Yun Si, are you there? Tan Yun Si?
Yes, sir.
Tan Yun Si,
Yes, sir.
Can you tell me how far the alpha, beta, gamma can travel in the air? How far it can travel?
Alpha particles can travel several centimeters.
Yes. Beta?
Beta particles can travel several meters.
A few meters. And gamma?
And gamma rays can travel 100 meters.
100 only, a few hundred, no.
Several hundred.
Several hundred meters. Okay, good. Thank you. Okay, next is Ku Kian Ming. Ku Kian Ming, are you there? Ku Kian Ming? Ku Kian Ming, Kian Ming? Not there. Ku Kian Ming not there. Okay, never mind. I call other people. Liao Jingning. Are you there, Liao?
Yes.
Liao, okay. Now can you tell me now the speed among alpha, beta, gamma? How? The speed.
Alpha up to 10% of speed of light. Then
Yes.
gamma is speed of light. Beta is up to 99% of speed of light.
Yes, very good. Okay. Then what is the speed of light? What is the value of speed of light?
3 × 10⁻⁸.
Yes, meter per second. Yes, correct. Thank you. Okay, next question. Liao Xingxiang. Okay, Liao Xingxiang, are you there? Liao Xingxiang?
Yeah.
Liao, okay. Can you tell me how this alpha, beta, gamma behave in electric field? Inside electric field, how alpha, beta, gamma will behave? Inside the electric field.
Alpha particles has more deflection towards negative charge.
Yes, correct. Yes, very good.
Beta has large deflection towards positive.
Yes, correct. Gamma?
Gamma rays doesn't deflect.
Doesn't deflect, it goes straight. Then one more now. Can you explain why alpha go to negative? Why the alpha deflect to the negative?
Because alpha is positive.
Yes,
charge.
correct. Correct, very good. And last question, Liao. Why alpha deflect? Yes, less, but this beta deflect more. Why? Why the beta can deflect more? This one deflect less?
Alpha is denser.
What? Say it again. Alpha is
denser.
Denser lah. Bigger mass, we say, heavier. The mass is bigger. When the mass is bigger, right, it's more difficult to deflect. We say bigger mass lah, Liao, understand? Mass is bigger.
Yeah.
Denser also more or less the same meaning lah. Denser mean the mass is bigger lah. But it's better to use the word mass lah. Mass bigger. Okay, bigger mass. Okay,
Okay.
Thank you. Okay, Liao. Okay, next. Next is Chiu Tong. Chiu Tong. Chiu Tong, are you there? Chiu Tong. Chiu Tong,
Yes, sir.
very
Yes.
tired, Chiu Tong.
Okay.
Chiu Tong, okay. Can you explain how alpha, beta, gamma behave in magnetic field? In the magnetic field.
In the magnetic.
How?
In the magnetic field, alpha move to the left, then beta move to the right. Follow the left hand flaming rule.
Correct. Okay. Then why this beta deflect more compared to alpha?
Because beta is lighter.
Lighter, yes, correct. Okay, okay, thank you, Chiu Tong. One thing we remember, never go and memorize alpha go left, beta go right. No, not necessary one. You have to use your flaming left hand rule to determine, It's too dangerous. You can memorize, you say alpha go left, beta go right. No. Not like that, no. You must learn how to use your hand, your flaming left hand. Okay? Always use the flaming left hand. That can simply change the direction of magnetic field. So you still need to learn using your flaming left hand rule to determine. Okay? Determine. So I tell you what, you only go and catch the alpha. You know why? I told you just now, because alpha is positive. When the positive charge flow, you also follow the current direction. So the direction where the alpha travel means the direction of the current. Understand? So your hand current is this one, second finger. So you only go and tangkap alpha. Just catch the alpha. If alpha go up, mean current go up. If alpha go down, current go down. Just catch the direction of current alpha. Okay, understand that? Yeah. Okay, so all the characteristics we have finished already. Now slowly take time, slowly one by one, we go and see the detector. Long topic, but important. Radioactive detector. Okay. We need a detector. We know this alpha, beta, gamma are very, very dangerous. That's why it's always to prevent ourselves from it is better, right? So to prevent it means we must able to detect it. So just like a pen, this pen like detector, carry a pen detector, put inside your pocket. When a detector gives you sound means your body is surrounded by radioactive, so you know already, understand? So you must use a detector, Okay? So many types of detector you in your syllabus, you need to study one, detector from a very simple one go to very complicated one, detector. Okay, now what is radioactive detector? Okay, detector make use of, okay, highlight ionization process to detect the radioactive emission. Okay, most of these detectors can detect radiation is because the radiation has ionization power. Because you can ionize the thing, then only you can detect. You can detect it because of the thing, this radiation ionizing gas, ionizing the air. Once it ionizes, then you can detect it. Okay, that is the reason use a concept ionization. Except for photographic plate, the first one never use ionization, just use chemical reaction. Okay, see the first one, photographic plate. Photographic plate or film, film means like those days when you want to take pictures, you need to go and buy the film, put inside your camera, right? That one is called photographic plate or film. Okay, this one not using ionization. Okay, you see what happened is the photographic film or plate can be used as a special batch or tag to record the dosage of radiation a staff at radiation lab is exposed to. Means those workers work in the factory involving radiation one, they will have to wear a patch every morning, wear a tag here, put in the pocket, hanging the tag. So that patch is photographic film, very sensitive. Once you kena radiation already, the patch will change color, become black. Black color. You see the patch, you take out, wow, you see black color already. Then you have to run to the hospital already. You kena already. So that patch is very, very good for you to detect. Okay. Okay. The detector work on the principle of radioactive radiation can cause a chemical change on the plate and produce a dark trace. Okay, the photographic plates got a types of chemical inside. This chemical when exposed to radiation, so it will carry out chemical reaction. Once a chemical reaction happen, it become black color. So when you see the thing change color already, means you kena already kena radiation already. So that one is photographic plate. But one thing you can know you kena radiation, but you don't know you kena which one, alpha, beta, gamma. You don't know which one. Okay, so also not so good but very convenient, not very cheap, right? Put in your pocket, you know already. Okay. Detector work based on a chemical reaction. The degree of darkening of the photographic film indicate the amount of radiation received. Become very, very dark means you kena the dosage are very heavy. If only darkened by a little bit, and that means very mild, a little bit only. Okay. The degree of darkening, the photographic film can detect all three types of radiation, alpha, beta, gamma. Please highlight, very important. You kena alpha, it become black. Kena beta, also black. Gamma, also black. All become black color. So you can detect all. So quite good, very convenient and cheap. Photographic film, one piece only you put in your pocket. Now you see, the black color already, then we no good. You never change color, means good. Okay, no radioactive. Okay, first one, remember, photographic plate, very simple. You can detect all. And then the concept they use is chemical reaction. The chemical inside, when exposed to the radiation, right? Because radiation carry energy. Once the energy go in, mixed with the chemical, right? Got chemical reaction, become dark color. Okay. First, second, gold leaf electroscope. Gold leaf electroscope, this one is also used to detect radiation one, But how then? Gold leaf, this is the box, okay, a box. inside the box there is a rod. This box is covered by glass. So it's transparent, you can see inside. It's glass, covered by glass. And then this is the rod. And then here is a piece of gold leaf. It's just a piece of paper made from gold. Gold paper lah, put here. Okay. And then up here you have a plate, metal plate here, metal plate, iron lah. Okay. So what happened is like this, before you can use this one to detect radiation, right? You need to charge it first. Charge it. Don't look at this here. You want to charge it means use your finger, touch it. Use your finger touch here is you neutralize it. Neutralize. Why? Because let's say this is positive, use a finger to touch. So all the electron from the ground go through your body, go inside here, then neutralize already. When neutralize cannot be used one, So you want to use it, you must charge it first. Charge. When you want to charge it like this one, you take a piece of ruler, use a cloth to rub. Rub the ruler, got charged already, right? You put the ruler touching the plate, touch the plate. If the ruler is positive charge, right? So the ruler touch, use a charged ruler, touch here. This one ruler got charged already one. Use a, so you touch here, so the positive charge will come here. So positive, it will repel. So you can see this gold paper open up. The gold paper open up. Okay. So first step, you charge the thing, charge the thing. So use a ruler, rub the ruler, got charged already. You touch here to charge it. To charge it means this thing will open up. You charge it positive, it open. You charge it negative, also it open one. You know why? Because when this one is positive, you put here, become positive. So positive, so repel, open. If this thing is negative charge, right? You charge this one negative, also repel, so you open up. Once you see the gold paper open up already, that means it's ready to use. Ready to use. Understand? Okay. Now, when the gold leaf is open up, right, and then ready to use, then you want to test the source called radioactive. You put the source here. When you put the source here, when this one got radioactive, right, it will ionize the A. Once the A ionized, so it produces positive and negative ion. Okay, these radioactive things are ionized A to produce positive and negative ion. What happens is, because this one here is positive charge, so the negative charge will be attracted, come down to neutralize all this positive charge. Once this positive charge neutralized by the negative ion, right? So it will collapse. You see the gold paper cool down, and that means this thing got radioactive. I repeat again, when you charge the thing, electroscope, the leaf open up. Once the leaf open up, it's ready to use. And now you want to test this thing got radioactive or not, you put the thing near here. If this thing got radioactive, right, it will ionize A to produce positive, negative ion. And then the negative will be attracted here because this one positive, attract the negative, come down to neutralizing. So all this positive can cancel already, neutralize. So no more repulsive force, it will collapse. When you see the gold leaf collapse means not good. That means this one got radioactive. When you put this one here, no effect on this, means this one no radiation. Understand? So how very easy lah. When you see the gold leaf close up, means this one got radioactive. Okay. When you put this thing here, no effect on the leaf, right? Means this one no radioactive. Okay. But one thing no good. This one only can detect alpha. You know why? Because only alpha has a strong ionization to ionize A. Produce positive, negative ion, then go down to neutralize. That's why this machine can only detect alpha only, beta, gamma cannot be detected. So not so good gold leaf electroscope. Okay, read through it. When the charge splits of electroscope is exposed to the source, the gold leaf will collapse. You see, when the gold leaf is collapse, means got radioactive. This is due to the ion produced by the radioactive source neutralize the charge in the electroscope. Beside the gold leaf come down, neutralize already. Highlight this method suitable for alpha only. Detect alpha because alpha have high ionizing power. Right, this is new ionization power lah. You might ionize the A, produce ion to neutralize the thing, then only the gold leaf will collapse. Okay, remember lah. Gold leaf electroscope lah. Okay, one more we call spark counter. Spark. This one slightly better. Spark counter means I can produce a spark. You can see the spark come out when you can see spark, like that. Because spark means radioactive. Okay, okay. This device is like that now. You see, this one is extra high tension power supply. This one negative. This wire gauge is negative. Negative is cathode. This is cathode. Negative. This one positive is anode. Positive. And the distance is only 2 mm. Very, very close one, actually. Okay, this one negative. This one is positive. Okay, in between the distance very close, 2 millimeter. Okay, what happened is, this one no need to prepare anything one. You just put the thing you want to test, put near high, put near it. You want to you take this soft, put here. I want to test this one got radioactive or not. Okay, what happened is, when you put this thing source here, when this one is having radioactive, right, it will ionize the A. Once again, the A inside is ionized, break up to positive and negative ion. Okay? Ionize the A. So use the concept ionization also. Must ionize the A. So once the A become positive, negative, or what happened now is the positive attracted to negative. So you move lah. This one move to the positive. Positive move to the negative, sorry. Whether this negative ion will attracted to the positive and not. So when they move, right, they will collide. When positive move to negative, negative move to positive, they will collide. When they collide, they will produce spark. Okay, then you can see the spark. Now, then over here got spark come out. When you see the spark means the ions are moving, colliding. That means got radioactive lah. So the spark, remember when you see the spark means got radioactive. When you put this thing here, no spark means no radioactive. Okay? Yeah. So also use the concept ionization. When the radioactive source is brought near to the spark counter, brought near here, the spark are formed. You can see the spark come out here. Okay, for spark. The radioactive ray will ionize the A molecule. See, the radioactive will ionize the A to produce positive and negative ion. So what happens is, spark are formed due to collision between the ions and the A molecule when they move up. When the ion move, the ion collide among themselves. The ion also will collide with other A molecule. So when they collide, then you can see the spark. Okay? Yeah. The spark counter can only, this one no good, no? You see highlight, only can trace alpha. Because only alpha has enough high ionizing power can be detected. So meaning that this machine also not so good because it can only detect alpha. Can only detect alpha. Need ionization to produce an ion to see the spark. Okay? Can I understand? Okay, I go one more lah, this one is a pest, I tell you. Geiger Muller tube, GM tube. This is a pest. Oh, so many of right? This is a pest. Most sensitive. Most sensitive means you can detect all. Alpha, beta, gamma can detect. And then This thing I will say is too sensitive, you know. You know why too sensitive? Because it's just like a pen, the size like a pen only, like a pen. You can put inside a pocket one. Okay, this thing when you on it now, you can already hear the sound. It like that. Because too sensitive, you know why? This GM tube can detect the environment surrounding radiation also can be detected one. Okay, let me tell you actually surrounding in our environment surrounding also got radiation one, you know, the soil, the air, the rock, sunlight, human body also got radioactive. Beside this machine, when you on already, straight away you can hear sound one. Every time when you on, you can hear tick, 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 tick. This is called background radiation. So it's detecting the background radiation, like from the air, from the land, from the sunlight, from the tree, from the rock. All this also called radiation, human body, right? So this machine is very sensitive, can detect the background radiation. This one is like zero error, you know, because you haven't go and test anything, you just only got sound already, also got reading already. This is something like zero error. Need to be minus later on, do correction. So you on it, you see got reading or got reading. That reading there is the background reading. You have to jot down because later on need to do correction one. There you see the formula. The actual reading, you must take the reading recorded minus the background reading. Remember, this machine got background reading one, you know, like zero error. You have to minus the zero error. Okay, very sensitive. Okay, how this thing becomes so sensitive? You see, this is a tube, just like a size of a pen, a tube. Inside the tube, here you have something, a piece of filter. So we call it thin mica window, a filter. This filter, mica window, only allow the small particle go inside. Big one gonna block already, cannot go in. So only allow the small one go in, so it become very sensitive, you know. So this is a function of mica window, is a filter, filter. So it block the big one, only allow the small one go inside. Okay? Yeah. And another thing you need to know. Inside here got a wire. This one is positive and not. And not is it connect to positive, right? And not. Okay? And this one negative connect to the body. The body of the tube is cathode negative. Not metal cathode negative lah. Me inside the wire is positive. Outside the body metal one is negative. And not cathode inside is anode. So then you got argon gas inside at low pressure some more. They purposely put argon gas inside and then make it low pressure. Why? Why they make it low pressure? Because when inside pressure is low, outside pressure is high, so the radiation will be pushed inside. This is the reason why it becomes very easy to detect. A little bit radiation also can be detected because inside low pressure, outside high pressure, so everything also will push inside. So very easy to detect, so very sensitive. So remember, argon gas at low pressure, no, they put argon gas. Why? Why they don't put air in low pressure? No, they put argon gas. I want to prevent this anode, so that this anode not easy to be oxidized, so can last longer. If you don't put argon gas, this thing very easy to become rust, oxidized, so not lasting. So they put argon gas to prevent oxidation. Okay. Yeah. What happens is like this, when the radiation go inside, it will ionize the argon gas. So the argon gas break out of positive, negative, right? Positive ion, negative ion. So what happens is The positive ion attracted to the cathode body, whereas the negative ion attracted to the anode positive. So once again, the ion move. When the ion move, it produce a pulse, produce a small current. I say it again. When argon gas is ionized by the radiation, so you have positive, negative ion. Positive attract to the negative cathode. The negative attracted to the anode positive. Okay. So when this ion's moving, right, move of ion produce small current. So this small current we will record here, will be count here. The more current counted here means stronger radiation. When the current produced here is very small, means the radiation is not strong enough. Okay, just see the current. Okay, now look at here. A GM tube is very versatile, very lasting now, sensitive. Because inside low pressure, outside high pressure, push it in, so very sensitive. And useful detector for radiation. When the radioactive radiation enter the GM tube through mica window, must go in from here one, and ionizes the argon gas. Argon gas been ionized already. A pulse of current produced, then you can see small current and counted by this machine. Okay, that is how to detect the radiation. When got current come out here, mean got radiation. Okay. The actual reading, you must take the reading recorded minus the background reading. I remember that. So on the machine, record the background reading first, and then only you go and measure. Okay. Okay. Now next, a little bit more. Yeah, here. We're talking about background reading now. Highlight. Background reading is produced by radioactive material from the earth, from the surrounding, such as stone, sand, soil, etc., and also from the cosmic ray from the sunlight. All this got radioactive one, background reading. Okay. Highlight. GM tube can detect all alpha, beta, gamma. Okay, can detect all. Very good. Good, but not perfect. It can detect alpha, beta, gamma, but cannot differentiate alpha, beta, gamma. And you hear got sound, mean got radiation. When got alpha, is also beta also gamma also so can detect all three now, but you cannot differentiate them. This is the only weakness of Geiger-Müller tube. Okay, so I think for today I stop here lah. So you go and read again. Photography plates, okay, gold leaf electroscope, spark counter, Geiger-Müller tube, read again. Okay. So 10 o'clock already. I know you all some very tired already. Some you still need to rush for your homework. Tomorrow still a school day. Okay. So I think I want to stop here. Anything? Got anything to any question want to ask here or not? Ika Chuan, Huixin, anything to ask? Chuan, got anything to ask or not? Tomorrow cuti. Who say cuti one? No. No cuti lah. Tomorrow is a normal school day. Okay, no cuti. Okay. All right. So remember, next week, follow your own time. You know, if Tuesday, you join the Tuesday one. If Thursday, you join the Tuesday tuition time. Okay. 7:30 we start lah, so that you can finish earlier lah. Okay. You can go and sleep early. Okay. Or do your homework early. Teacher, can you send me the recording? There's a problem with my connection. Okay, I will send, I will upload in the YouTube lah. I will share in the WhatsApp. Okay, don't worry. Okay. For today one, I still do that lah. But next week, maybe I don't have the time to go and upload in the YouTube already. So you must follow the online class next week. Because once in a week only, you must attend. Okay. So I don't want to waste time to upload video lah. I need to spend a lot of time to upload the video one, you know. Okay. 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 So I see you again next week. Okay, bye bye. Take good care.
Thank you,
Huh?
teacher.
Yeah, bye bye.
Thank you,
Bye bye.
teacher.
Yes, bye bye. Okay, bye bye.
Sir.
Yes.
来 ，OK 啊，喜欢那个上个礼拜的东西啊，可以问你关于那个我们哦，你讲的是讲 hospital 是用多少电哦？
什么啊
？hospital 是用多少 volt 的电？是415还是那个是1 kV 吧？是？因为我那天我问办公，他没有回答我，他跟我讲肯定是more 电
？400啦，400多罢了啦。
415啊。
shopping center 这种400多，如果是11天那些都是工厂大间那种哦，有大型重型工。
它不是有分那个 light 的咩？那个这种小型的工厂，小型不是它不是有分小型的工厂啊？
小型的工厂是400多罢了用。
对，不是1啊？哎，
什么啊
33不是33。
33是轻工业区的轻工业。
对了 ，light industry 吗？
啊，对了。
有红门啊，
哎呀，忘记了嘛，要这样。
怎么老师怎么了？我觉得老师这样快啊，喂，老师要玩我。
但是
天。
第二个礼拜的嘛，都是那个不要太过担心啦，因为那个只是给你们做 practice 罢了的 diagnostic。
等于是 OK。
给你们知道自己的水准罢了啊，没有影响的啦。OK 啊。
这也是要读诶，没有读也是不会的。
读 Form 4的咯，Form 4的 topic 读多一点嘛啊。
老师是你出嘛？
那个题目我跟你讲，很多我们做过了的，就是那些我给你们的 paper， 那些 paper 后面那些 tutorial question 你去看多一点啦。
OK， 可以。
每个 topic tutorial question 去看完它 ，OK， 拜拜。
Spoil 出来 ，OK。
拜拜啊。
拜拜。